Okay, I wanted to I wanted to pick up where I left off here last time. I worked out this problem, but I didn't really explain very well what the E was, and so I just kind of wanted to re-go over what E is, and then we're going to graph this graph down here. When you see an E in the world of mathematics, it's a constant base for a natural logarithm, and in section 4 dash, or in chapter 4-3, section 3, we're going to talk more about logarithms. You've probably seen the E before in Algebra 2. But this is kind of like pi. It's not a variable. It does equal an actual number, and in this case, it's 2.71828, and then, it keeps going. It's irrational, so it doesn't stop. But when we're working this out, the E, even though it's not a variable, you just kind of treat it like a variable until it's time to change it. But I just wanted to make sure that we were all aware of that. And you do have an E on your calculator, or at least you should. Okay, so let's graph our exponential function here. And we haven't done a lot of these graphs yet. Well, we've done a lot of graphs, but we haven't done any exponential graphs yet. So for those of you who don't remember, the exponential graph, and it's funny that we're talking about exponentials right now because our country's going through the coronavirus crisis where it's actually growing at an exponential rate, the number of cases that, the U.S. sees. And exponential just basically means that it starts off slowly and then all of a sudden there's a sharp increase or a sharp decrease depending on which way you look at it. So, talking about exponential growth and exponential decay, that all kind of goes back to these exponential functions. And so this is kind of the basic look that you're going to see here, and of course it also depends on a lot of stuff that's going on as well. Just like with every other function, the easiest way to do this is literally just to do a t-chart, and just to try to get as many points that are whole numbers as possible. With exponential graphs, it's sometimes hard to get whole numbers, so I'm just going to do the best I can using Desmos to try to get this table to show up. And if you're not sure how to use Desmos, remember, you can always plug in values of X and just see what Y value comes out. And like I said, anytime you get a whole number, or in this situation, anytime you even get a half, 0.5, I would probably use it too, because exponentials, there's not a lot of whole numbers that we can pull. Okay, going back to Desmos here, I already have it typed in, and as you can see, I had to actually put the exponent in parentheses to keep it all as the exponent. But make sure you call it f of x. And I see the graph over here, so I have an idea of what this is going to look like. Now, to pull up the table or the t-chart, we're going to actually hit the plus sign. We're going to go to table, and I just want you to change this y of 1 right here. Let's change that to f of x, since that's what we called our function. And the other day I couldn't get this to work, so I'm hoping that it'll work for me. Uh-oh. Okay, so f of x. Okay, and sometimes you have to change it to like f of 1 of x. It's really weird, like a little sub 1 there, how this works, and for some reason it's still not working. Why is this not working for me? Anyway. Go back. Delete. Let's do a lowercase f and see if that works. Is that better? Or maybe I have to use this keyboard. Maybe that's what it is. Does it want me to use this? Yeah. Anyway, usually, and this, I bet that's what it wants. It wants me to use that little keyboard. Oh, okay. So let me go back here. Instead of using my personal, the keyboard that I typed on, it wants us to use the Desmos one, which makes a lot of sense. So let me just type this in. F of x, and I want to change this again to f of 1 of x. There we go. That's better. And then if I type in, let's try negative 14. I'm going to start with that just to see what happens here. It's still not working. Maybe I need to change this too. Let me use this keyboard right here. So I think it has to completely match up. Okay. Well, something's going on with the table situation. I'm really not sure, what's going on with the table situation. But, if this happens, if all else fails, like I said, we can always plug in some numbers. So I'll start with f of negative 14 because that's the one I wanted to do. And I've pulled up the table previously, and that's why I know this is going to work. But if you actually type this into the calculator, then you'll find out that this is going to give you negative 3. So you're going to get a whole number when you type that in. Now, because I've already pulled up the table in the past, I don't really want to waste a lot of time showing you guys, all the different values that I got. But I'm gonna write down what, as far as like the numbers that I used here. I ended up using negative 4, negative 2.5, negative 3, negative 2, negative 2, negative 1, negative 1, 1, 0, 5, and then 113. Those are the ones that I chose to use. Like I said, I tried to use as many whole numbers as possible, and I do have 1/2 number in there, but it'll be just fine. Once you get those, let's just go over here to this graph, and let's just do the best that we can to graph it, even if it goes off the graph here. So let's try negative 14, negative 3. Okay, about right there. And now let's try negative 4, negative 2.5. It can be really hard to see, but it's like about right there. Negative 3, negative 2. It's right there. Negative 2, negative 1. Negative 1, 1. 0, 5. And 113. It's about right there. Okay, so we get a pretty good set of data here to use for our graph. Anything else is going to go off, but that is perfect. Now, to answer a couple of questions about this, first of all, it does have a y-intercept at 5. So if you had to tell me where the y-intercept was, the y-intercept is at 5. And the way you get the y-intercept, of course, is you plug in 0 for x, and that tells you the y-intercept. The way you get the x-intercept is you actually have to solve the problem for x, which is what we were doing, in previous problems from this lesson. The problem with this one is that you're not going to be able to solve this by changing the base to get a common base, which is what we've been doing. So this is where we actually have to do the logarithm stuff, which is where chapter 4, section 3 is going to come into play. All right, guys, I hope that helped, and if you have any questions, just let me know.